For a game that revolves around fishing and water, why does my water look absolutely horrible? Today I would like to show you how I created this water for my indie game. There's only 5 different layers, so let's go over it one by one. Right now, the water and land are the same image. Let's remove the water and put it on its own layer, so it doesn't affect the land and the docks. Then let's extend the water to fill the screen. Oh, and make sure the water is drawing behind the land image. Let's add a few more rocks and seaweed randomly on the floor. There, that step was pretty easy. The water looks very flat. In real life, the deeper the water, the darker the color of the water gets. This happens because of some complicated absorption and scattering with particles. But video games can't really have a 3-dimensional space for particles to interact with each other inside my monitor, like they would have in the middle of the ocean. Or at least they can't yet. So instead, we have to fake this effect by using something called a height map. This is a simple black and white image, white being the highest point and black being the lowest point. Most games use something like a noise function to make a procedurally generated map with high mountains and deep seas. But I have a map I made myself. So instead of using something like a function, I just loaded up some Photoshop, plopped in the image, selected the land, made it white, and gave it a pretty big blur. The blurrier the image, the longer it will take for the water to get deeper. Then we pass this texture into the same frag shader that the ocean floor is using. Then simply use the frag shader's magic and convert the white parts of the image to a light blue and the dark parts of the image to a dark blue. This is already starting to look way better than their original, but there's still way more we could do. You ever go swimming in a pool and see these weird light rings covering the floor? Well, they're called caustics. This happens when light passes through the moving surface of water and gets bent or refracted in different directions. The ripples in the water act like lenses focusing the light into bright shifting patterns on the bottom of the pool. For right now, let's just imagine that the water is moving. I'll come back to the ripples in a second. The most realistic way to render the caustics would be to actually calculate them based on the surface of the water. But caustics take an extreme amount of time to render if you want good results. So instead, we have to use some video game magic. We have to fake this effect just like a lot of the other effects I have and will describe in this video. Luckily for us, humans are amazing at spotting what's real and what's fake. And what's even luckier is that we are using pixel art, which makes it even harder to spot errors. But maybe I'm just trying to reassure myself that I did a good job. Anyways, we use a caustic texture instead. Then we tile it over the water to look like this. But caustics aren't a surface level thing. They sit at the bottom of the water. This means that as the water gets deeper, harder it is to see the caustics. So we just need to do the same calculations we did to the ocean floor. Then with a few other value changes, we are left with this. To calculate ripples is a little more challenging. There are 3 different methods, or at least that I know of. The first is actually rendering each particle and its physics. Let me bring you guys back to chemistry class. Imagine we use the real life size of a water molecule, which is apparently 2.75 angstroms. This means that one molecule of water, or this crazy number, is only around 18 grams of water. Just to imagine the scale of a mole, let's try to imagine it using different items instead of a molecule. If you had 1 mole of sand, you would have enough to cover the entire Earth's surface, including oceans and a layer many kilometers deep. If you had 1 mole of pennies and stacked them like a tower, it would stretch from the Earth to the sun and back over 1 billion times. The 5090 has around 92 billion transistors, which are just binary bits, yes or no, which is already an insanely high number. This also isn't even enough to calculate anything close to the position or velocity of the molecule, but just go with it for now. If each molecule was assigned to a transistor, then you would need approximately 6.5 trillion GPUs just to render 18 grams of water. Okay, sorry, I went off on a little tangent. But pretty much all I'm trying to say is that it would be very difficult to render water using particles the size of water molecules. Since we're also using computers, we could just up the size of the particles. The larger the particle, the less accurate the simulation becomes. But we don't need something exactly right if it will save trillions of years of calculations for 1 frame. Although this method still looks pretty good, it still takes a couple of seconds to render per frame. And this doesn't even include lighting. It's just unplayable. The next method a lot of games use is called vertex displacement. This is when a giant plane with thousands of vertices is put into the game. Then the vertex shader is responsible for moving around the vertices vertically to simulate water. The math behind it is pretty much just a bunch of different sine waves with different amplitudes and frequencies moving in random directions. Then after adding some color and lighting, it looks like a giant tarp waving in the wind. But hey, all we're doing this for is to distort the image under the water. Although I was too lazy to actually implement this part, I thought it would be overkill for just a simple task like this. So this is what brings me to the third and final method. This method is called texture displacement. It uses a crazy texture called the DUDV map. This map is used to displace the UVs of the original texture. What are UVs? They're coordinates that objects use to project the texture onto. So a square like this and a texture like this would map to these coordinates. The coordinates of a texture always range from 0 to 1, 0, 0 being the top left and 1, 1 being the bottom right. So if I were to move around the UVs like this, then you could see the texture get stretched and squished. If we do this enough times in the correct way, we could fake a water texture. The DUDV map is full of colors. These colors represent a position from 0 to 1 on the X and Y. Then we again use the frag shader's magic to convert these colors to numbers and numbers to offsets for the texture. We are finally left with nice and wavy water. If you look closely, you might notice something wrong. My game is all about pixels. You can see them here, here, and here. But when we distort the ocean floor, it's distorting smoothly, which looks nasty. Take this image for example. Right now, the distortion looks like this. But I want it to look like this so it matches the pixelated look of the rest of the game. So how would we go about doing this? The best method I've found was to get the center pixel from each of the virtual pixels. If you don't know, my game's pixels are 3 pixels tall by 3 pixels wide. So I would use the pixel in the center. And whatever the color was, I would set it to every pixel around it. This is the before, and this is the after. I think the pixelated look looks way better. The last and final step is to add reflections. In normal 3D, you would render the map from directly onto the player. The reflection camera would be the same distance away from the water's surface as the actual camera, but just below the water. From here, the camera is rotated in the opposite direction vertically, so its look vector lines up perfectly with the actual camera's look vector on the water's surface. This gives the illusion of reflection, while being able to see the bottom of the object. But this method requires 2 render passes. One's to make the reflection texture, and the second pass to render the 3D models using the reflection texture. But more importantly, we can't use this method because my game isn't in 3 dimensions. You might know this, but you can't just vertically flip an image and show the bottom side of the object. Wait, that actually just worked? Then again, we pass this texture into the frag shader and apply the same water distortion onto it. And this is what the final water should look like. Okay, I lied. This is actually the last step. But it's pretty quick and simple. The actual last step is to make the shoreline move. I'm going to warn you now that this visually ruined the shoreline animation for me, but instead of doing some complicated thing in the fragment shader, why not just hand animate the sand? So I simply threw it in Sprite, then remove 1 pixel from the bottom every frame. This doesn't look right. The shoreline shouldn't be linear. Instead, I duplicated and removed some frames to make the animation look more shoreliney. Then I also added a little bit of wet sand and some foam to the shoreline. I think this method looks incredibly better than what I had previously. It's no longer just a simple blue image, we now have lots of movement in the scene. It finally looks like a habitable place for fish to live.